Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 16 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 190, reverse bits. So you have to reverse bits of a given 32 bits signed integer. So here if you see example number 1, if n value is like this, so in binary form we are going to write it like this. Now we have to just reverse this. So here if you see two zeros, so here these two zeros, then three ones, then here you see three ones, so we just are reversing it. And if you see the constants, so n value is from 0 to 2 raised to power 31 minus 2, and n is even. So how we are going to do this? So let's understand this. So initially let's say you have number like this 10100, and this, if I write this number in decimal form, so it is nothing but 1 2 4 8 16. So this is nothing but 20. Clear this part? So this is 20. Now I have to reverse it. So if I reverse it, what is the output I'm going to get? This 0 comes here, then this 0, then this 1, then this 0, then this 1. So this is the what you are going to get. This is the result, reverse order, 0 0 1 0 1. And this is nothing but 1 2 4 8 16. So this is nothing but 5. So 5 is the output that you are going to get. So now let's see how I'm going to reverse it. So this is very simple. So first, what you need to do, initially let's take your result value as, so I'm not taking all the 32 bits into consideration as of now. Let's just take 5 bits. So for short example, let's understand first how we are going to reverse, then you can reverse it for 32. So what I will do, I will take the result like this, 0 0 0 0. This is the result that I'm going to take. Then after that, I'm going to run my I loop, and I loop is going to start from 0 to 4. So it is going to run for 0, then first bit, then second bit, then third bit, then fourth bit. In overall 5 bits are there. So when your I is equal to 0, so what you have to do, once your I is equal to 0, so once your I is equal to 0, in that case you have to take the result and left shift the result with 1. So this is the first thing that you need to do inside the loop when I is equal to 0. Then after that, whatever the value of n you have, let's say this is your n, so you have to do the n and of n value with 1. So that simply means you are just taking the last bit, because you know that if you have something like this and you do the and of this with 1, so if this is 0, so you are going to get 0 only here, all are 0 only. But if this is 0, you are going to get 0. But instead of 0, if this is 1, so you are going to get 1 here. So that simply means I'm just taking this into consideration. So I'm taking the last bit, and whatever the result I have, I will do the OR of this result with this value. And then after that, whatever the n value, I will just move this to the right shift. I will just give the right shift. So here I will write like this, right shift by 1. That's it. So this is what I need to do for I is equal to 0. Then same way for I is equal to 1, again I have to do the same things. Then for I is equal to 2, again I have to do the same things. For I is equal to 3, again I have to do the same things. Then for I is equal to 4, again I have to do all this same stuff. So this is what I plan to do. So here initially your result is 0 0 0. So if you left shift your result by 1, so you are going to get same thing na, 0 0 0 0. Then after that, n and 1, so you are just going to get the last bit of n. So your n is like this as of now, 1 0 1 0 0 1 0 1 0 0. So last bit is 0 only. So again you do the OR of a result, so you're going to get 0 0 0 0 only. And then you have to shift n to the right by 1, so you are going to get all the bits move to the right. So you are going to get something like this, 1 0 0 1, and here 0, like this. So this is a new n value you are going to get. Then same way for I is equal to 1, again result is still this 0 0. So okay, if you do the left shift by 1, so you are going to get the same thing here. And then again the last bit is, again if you see this n, last bit is again 0, and result overall it will remain 0 0 0 only. And then you have to right shift n by 1, so you are going to get something like this, 1 0 1 0 0. This is what you are going to get. Then for I is equal to 2, again your result is this only. So again you have to left shift the result. So here this is nothing but left shift, left shift. This is nothing but the right shift, right shift. So left shift the result. So you are going to get again 0 0 0. And now after that the last bit of n is 1. So you are going to get 1 and the result is 0 0 0 0 0 or with 1. So you are going to get a result like this 0 0 0 1. Clear this part? You can do it now. Result is 0 0. The result is this, and if you do the OR of this with 1, last bit is 1, so you are going to get this, right? And then you have to again right shift the n by 1, so you are going to get something like this 1 0, and here 0 0 0. This is what you are going to get. Then for I is equal to 3, again you have to now left shift result by 1. So result is this from last time, so left shift by 1 0 0 0 1 0. This is what you are going to get. Then after that here last time this last bit is 0. Okay, so again result or with this again 0. So or with the 0 simply means it will remain the value equal to result only. And then you have to again right shift the n value by 1. So you are going to get something like this 0 0 0 0 1. This is what you are going to get. Then in the next case again your result is this, so again you have to left shift the result by 1. So you are going to get 0 0 1 0 0. This is what you are going to get. Then after that n and 1. So last bit is 1, so you are going to get 1 here and 1 over with the result. So that simply means you are going to get this. Clear this part? And then again you have to do the right shift of this, so you are going to get 0 0 0 0 0. That's it. So see, in the end your result is this, which is nothing but 0 0 1 0 1, which is nothing but this 5. That's it. So here I am running the loop from I is equal to 0 to 4, but in your case you have to run the loop from 0 to 31, right? So that simply means 32 bits because it is starting from 0. That's what you need to do. That's it. So let's write the code. Whatever explained, the same thing. Very simple code also. Here int result is equal to 0, and here you have to simply run one loop for int I is equal to 0, I is less than 32, and here I plus plus, and here after this you have to just update the result. So result you have to do the left shift by 1. So here this is nothing but shift result left, and then after that the n values, so we have to just take the last bit, so n and 1, and I will just do the OR of this with what, with result. So here result, and I will just update the value of OR. So result is equal to result or n and 1. So that simply means what I'm doing here, add last bit of n, and then after that what I need to do, we have to right shift the value of n by 1. So n is equal to n left shift 1. That's what I need to do here. So here this is nothing but shift n right, and in the end here just simply return the result. That's it. So now let's run the code. So see, all the test cases has been passed. Now let's submit it. So the time complexity for this is going to be of 32, so you can say of 1 only, right? So I hope that you guys are able to understand today's problem, and if you guys still have any questions, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Until the next video. Thank you. Bye bye.